Hi guys, welcome back. In this demo, we will look at the user-defined functions in SQL Server. So, user-defined functions is one of the important and the main programmable objects in the SQL Server. So, in this demo, we will look at what is a user-defined function and the different types of user-defined function, and we'll also look at some other aspects of user-defined functions. Like, we'll go in detail of the different properties of UDFs, and also we'll develop a simple UDF. And also their advantages and limitations. When coming to the UDFs, it is better to know the limitations because the limitations to the UDFs are more when compared to the advantages. So there is a fine line of gap between the user-defined functions and the stored procedures. So you have to be familiar with the limitations in order to decide how you want to write or how do you want to write your code in a UDF or in a stored procedure. And we'll also look at the how can you use a scalar user defined functions in the computer columns, and we'll also look at what is a deterministic function and what is a non-deterministic functions and how do they affect our UDFs, and how do they affect in creating indexes on the computer columns and also on the indexes on the views which uses these functions. And also we'll look at the performance aspect of UDFs and how can we change or how can we improve the performance. Okay, so our first question is what is a user defined function. A user defined function is just like a store procedure. It is just a prepared code, and it accepts a parameter and returns some kind of, and it calculates and it does the complex calculations as we develop, and it returns a value, and the value can be a scalar value or it can be a result set. So when coming to the other question, the different types of UDFs, depending upon what UDF returns to the user, the categories of the UDFs will change. Basically, there are two types of categories in the UDFs. One is the scalar functions, user defined functions, and another one is the table valued user defined functions. So in turn, in the table valued user defined functions, there are two subcategories. One is the inline table valued functions, and another one is a multi statement table valued functions. We will go in depth in these functions, but first we will go and look at the different benefits that we have in a user defined function. As I just said, user defined function is just like who are new to the SQL Server, is user defined function is just like a method in any programming language or in any object oriented programming language. So what does a method does is a method, or it may take a parameter, or it may not take a parameter, but it returns a value. It's the same here. The UDF, it may take a parameter or it may not take a parameter, but it returns a value depending upon what value it returns. And the user defined function it is differentiated between different types, like the scalar or the table valued function. So once the benefit of the UDF is, once function is created, you can store it in a database, and you can call how many number, and you can execute the function how many times you want, instead of having a simple ad hoc SQL executing from an application to a database. You can use this UDF to optimize your code. So as just like any compiled and executed code or parsed code, it has a faster execution, and it does not need any re-optimization until and unless if it is the tables or the views which which are utilized by the UDFs changed. And ultimately reducing the network traffic between the client and server, or host and server. So when coming to the important topic of the one of the important topic in this discussion is what are the limitations of UDFs. So there are different disadvantage. I mean, there are different. I would not say a disadvantage, but I would say limitations. There are different limitations that you can use a UDF in a particular way. So we will list the main and important limitations in this. Almost there are like 10 different limitations that we have in the UDFs. So um, so the only so first an important one is the functions which perform in a deterministic manner can be used or create indexed views or creating indexes on the computer columns. First, just try to remember this point, because uh, we haven't talked about the deterministic manner of a function, deterministic and non-deterministic manner of a function. So once we go to the topic, you will better understand this point. And the second one is you cannot insert or update rows in a table other than a table variable, and all the statements inside the function body, mm, all the statements which are inside the function body should not affect or change the state of the database. We'll also look at this point in detail later. And you cannot call any store procedure other than the extended store procedures. So and a function can have a maximum of 2100 input parameters. So this number is changes depending upon the type of or the version of server, SQL server that you are using, and continuing the limitations only. So user defined function can only have one output parameter and and a single result set in case of an inline or multi statement UDFs. So it can only have, it can only return one output parameter. And but in case of one output scalar output, and in case of table valued function, it can return only one result set. So and the UDF can accept any type of data types in the SQL server except the time step. And also it cannot it should not we cannot use the dynamic SQL or for XML inside the function body. And it does not also support it doesn't support the error handling or the try catch loop. So these are the basically the limitations that you need to remember when you're dealing with the functions, because once any of these once if you do not agree or you find uncomfortable with any of the limitations, then you better opt for the store procedure or any other kind of code in the SQL server. So now we will look at a basic syntax of a user defined function here. So in this, so this is the basic syntax or different components of user defined functions. You have we will divide this entire syntax of the user defined function into two different sections. Basically the one which is on the top here, which you can see my mouse here, is considered as the header part. Until with, so until from create function to as is considered as a header part, and below as is considered as the body of the function. So there are two parts in the function which are mainly we will be dealing with in order to understand the different types of functions. So uh, now we will go in depth and we will understand different options in this syntax. Okay, so here this is the uh, oops this is the entire syntax of the user defined function, which is divided into different categories. If you look at the top here, the create function is just like any create syntax, which you specify the function schema name and also the function name. So the schema name, if you didn't specify it, and if you're database owner, so automatically the DBO is appended to the schema name. If you're not, then the username is appended to the function name. And as we just discussed, that it takes a parameter, it takes a one at least minimum of 0 to 2100 parameters. So you specify the parameter here and the data type. You can also specify a default value in case if you do not want to provide any input parameter during the execution. You can specify the default value here, and you can also specify read only. Basically when you specify read only, the parameter cannot be updated in the function of the body. So so this part is the input parameters part, and the next will be the returns. I mean basically you're defining this function what it returns. In this case we are just returning an integer data type. This, when you're returning a scalar value, then this is called as a scalar UDF function. Depending, as we just discussed earlier, depending upon the type which is returning, this function is defined in three different types. If it returns a scalar, then it is called a scalar user defined function. If it returns a table, then it is called an inline table valued function. If it returns a table variable, then it which is declared in here in the header part, then it is called as a multi-statement table valued function. We will go after completing this slide. We will also learn the writing a simple user defined function. Okay, now one of the important aspect in the user defined function is that you can specify the different options for a user defined function. Here you can see the different options available in a function: encryption, schema binding, execute as, clause, and also returns null on null input, or you can only specify one of these. So returns null on null input or called on null input. So when you specify the encryption option, the user defined function is, and the body of the user defined function is encrypted. So uh, we will also look at this once we start developing a simple user defined function. The And coming to the schema binding, the user it prevents, what does a schema binding does? It prevents any object that the function refers being dropped or changed. So it throws an error message saying, hey, you use this table in this function, you cannot modify this table or something like that. So, and execute as is the same is exactly the same syntax as any execute as clause, which impersonates some other user accounts in order for the function execution. And the next one is what it returns when null input is provided. So if you specify the returns null on null input, basically the function is not executed. Once you specify null input with this option turned on, you will, without proper execution of the function body, the null output is returned. But if you specify the called or null input, although you specify null input, the body of the function is executed and it returns whatever value the body of the function returns. So and this is the basically the syntax of the user defined function. So once you, after the begin in between the begin and end, as we know that we consider this as the function body. So now we will go a simple user defined function. First we will develop a scalar user defined function, so that way we will understand that how a simple UDF is written. So here I've written a simple user defined function. What it does is it takes a temperature, which is an integer. Basically what I want to write is if somebody gives me a temperature, basically what I'm doing is I'm converting the temperature scale from Fahrenheit to Celsius or Celsius to Fahrenheit, depending upon the input parameter specified. So here you can see my function has two parameters: the temperature, which is a int, and the scale, which is a character. So which returns a float. I mean, the float is a type of data type which it returns. And we are beginning our function body here with the begin statement, and first we are declaring a float, a temporary variable here, and a ctemp float data type variable. And if the scale is Celsius, then we are performing our calculations here and setting that value to the ctemp, which is the variable that we declared earlier, which we're going to return after the function body is executed. So we are setting the ctemp to this calculation here to convert the so from Celsius to if you want to convert from Fahrenheit to Celsius. If you want to convert from Celsius to Fahrenheit, then you set the ctemp option with the desired calculation, and at the end at the end of the function body, you return, before ending the function body, you type the type of you type the return statement with the variable that you want to return, with the scalar variable that you want to return, and also end. So basically this is a simple scalar user defined function which is converting a temperature scale from one type to another type depending upon the input. So here now we return this simple function. We execute this function. Basically once you executed this function, it is stored in the programmability and functions. So as this is a scalar, there are different, as you can see, the functions are categorized here: system functions, aggregated functions, scalar user valued functions, and also table valued functions. So as this is the scalar valued function, our function is stored right here, the temp convert. This is the function that we executed here, which is stored in here. So this is how you can view your function in the programmability objects of the SQL Server database. So let's go ahead and execute. So here we have a simple select statement and also the function here with the 23 is the integer, and we want to convert this to Celsius. Okay, so let's execute this and see the output. Oh, sorry, should specify the use here. So now we can execute the function. So here the Celsius, the Fahrenheit is converted into Celsius. So here is the converted output. So you can see here, basically we just written a simple scalar UDF and converted a temperature from one scale to other scale. Now one more important thing is you can use the function. Function can be used in many places of a query. It can be used in a select, or it can be used in any joining conditions, or it can be used in any where class. So the different places where a user defined function can be used, a scalar user defined function can be used. Now, and here I have written one more scalar user defined function. Basically what it does is it converts the weight from one scale to other scale. It converts the weight from kgs to pounds, or from pounds to kgs. So here it returns the float, and once you have a begin statement here, we will declare a simple variable that stores our converted value. So if the scale is pound, then we are multiplying the weight with the 2.2. If we want to convert into kgs, we are dividing the pounds by 2.2, and we are returning the C weight, which is the data type which is the variable that we are storing our converted output. So here is a simple scalar UDF that we written here, and let's see. Right now here I'm converting the 70 to pounds, 70 kgs to pounds. So I just execute the select statement here. Once I execute the select statement here, so you can see here the converted output, which is converted into kgs depending upon the specify. If you want to convert this to the pounds, you have to specify the parameter here and then execute the statement. So here, so now create function. Okay, so we seen the first type of the user defined function, which is the scalar user defined function. Okay, right here. So we just saw the scalar defined function. We'll also look at the table valued functions and here. So the main difference between the scalar user defined function and the table valued function is that what type of what it returns. In the table valued function, basically it returns a table or a result set. So we'll look at here. Okay, so here is the function which I have written. Okay, so this is the function basically which returns this is an inline user defined function. Inline user defined function. Here you can see it is just returning the table. So although the inline user defined function and the multi-statement user defined function returns only a table, the inline user defined function returns a table, but multi-statement user defined function returns a table variable. So here the syntax between the inline and multi-line differs a little bit. So it returns a table here, and we specified the schema binding that I will try to demo you what it does. So it returns so here what it is returning, name from a table by specifying the product ID that we are passing in this parameter. So here you can see I can still pass a parameter for this function, for the inline user defined function, and I also specified the schema binding, which we will look at and see what it does. So it returns a result depending upon the product ID that we specified. So here, why don't we just go ahead and execute this simple inline user defined function. So here we specify the function here, and the product ID is 4. So let's see what result we get. So here, this is the table that we are getting here. So select distinct. So this is the result set that we are getting here, which is a table. The output is a result set table, which is not like any kind of scalar output. This is just a table result set. So this is a simple inline user defined function. And coming to the option that we specified is a schema binding, right? Okay, if we specify the schema binding here, let's say let's make sure that we have schema binding on the function. Okay, so here we have the schema binding setup. Now what we will do is we go to this product table and try to change the data type of this name and see what happens. So here we have different tables. So the table we will be looking at is the product table, and we'll go to design, and we will try to change the data type of the name which that we are using to return in our inline user defined function. So when you try to change, it throws you error, or it throws you a warning saying the following schema bound object will be modified function, schema binding will be removed automatically. So what it's saying is the function that we use to write a simple inline where we specified the schema binding, the function binds itself to this object. So whenever this object is changed, it throws us a warning or an error saying, hey, this object you're using it in the UDF and you cannot modify here. So that's what the schema binding does. Schema binding also does more, but we will look at it in detail later. So okay, we are not going to save these changes, and the next one is that we're going to look at is the multi statement table valued functions. So here we have a simple function here, which is a multi select table valued function. It returns a table. Now you can see the difference between the syntax between the inline and multi-line. Basically the inline has it returns a table result set, but here it returns a table variable. So here in the returns statement, here I declared a table directly here, and also its properties, its columns here. And here I used the option called encryption, and basically I'm inserting into the table the table which I declared here, and what I'm inserting is a select name, list price, start date from the product where product ID equal to ID. So basically I am passing the product ID to this multi-line user defined function and returning the table. I'm returning this table by inserting the data that I want into the table. So if I specify here, let's say now you can understand basically a difference between the inline and the multi-select table valued function. So here you can see, if I execute this query here, it returns me a table like the same way which it did in inline, but it only uses a table variable. So what is the difference between inline? Inline is returning the table, but multi-line is also returning the table. Basically inline user defined function works more like a view, because once when an inline user defined function is executed, it just executes as a view. The select statement inside this table is executed, and it looks for any changes in this table I mean, as we specify the schema binding, it will not look, but if we not specify it, it looks for any changes and executes according to the statistics of the table. So the execution plan may change each time or during the period, but here in the multi-select statement, the execution plan is generated for only one row, because the table, when we are using the table variable, the execution plan will be only for one row, because the SQL server does not maintain any statistics for the table variable. So when you are using a multi-statement table valued function, basically the execution plan generated in the multi-select table valued function is only for one row. So basically there are going to be some performance issues, but it is better to always use the inline table valued function when necessary. So I mean, when coming to the encryption option here, what does it do? When you specify the encryption option, the definition of the function is encrypted. Okay, now before going into the encryption, first, now we have seen the all the different types of functions here, and we created a simple user defined function for each of these functions. So what if you want to view a definition of this function inside where it is stored? The definition of these functions or definition of any programmable components in a SQL server are stored in a catalog view called SQL underscore modules. So here I have written a simple query which does the same. Basically what it does is it queries SQL modules where the function definition is saved. Not only function, it saves the definitions of procedures, triggers, any programmable objects of the SQL server are saved in these modules. So we are using a join between the sys objects, where the objects that we're going to look was for the function, which is the scalar function, and also the inline function, and also the table line function. Once you query this, once you execute this, oh no, we are selected the master, so we're gonna, as this is the catalog view, the output of this catalog view depends upon the database that you select. So here, now basically these are all the definitions of the functions that we have inside this database. The type, in the type and the description, you can see fn means a scalar function, and if means a scalar, if means a inline table valued function, but tf means a multi-select table valued function. So here for the user defined function that we written here for the multi-select, the definition is null. You can see here the definition is null. So what it is doing is it is encrypting the data, and it is storing in inside, and the normal user cannot view this data. So I would suggest that we should be careful when using this encryption, because once the module or the definition of this user defined function is encrypted, it is very difficult to retrieve the definition of the function. Basically, when you encrypt the definition of the user defined function, the SQL server utilizes well, until the SQL Server 2008 and 2008 R2, it uses a RC4 encryption algorithm, and it takes the database GUID and the object ID as the key, and it creates an encryption stream, and it stores inside the system tables. But a normal user cannot view inside the, or cannot view even cannot view the encrypted definition here. Even though you cannot use the encrypted definition, even though you have the admin privileges to the database, because the uh, the only way that you can retrieve the encrypted definition of that function is using a dedicated administrative connection to the SQL server, or by using a simple debugging process, by attaching a simple debugging process to the SQL Server processes. When you once execute that function, when once it in the memory, then you can view that encrypted text or the encrypted module in the SQL Server. So it is not a better option to use the encryption option, because it would be very difficult to retrieve the function. Here in this case, we will try to retrieve the encrypted text. There is a small tool, a freeware tool that is available online, which is called SQL OptiLect SQL Decryptor. Basically what we'll do is we go to this in this we will in this first what we will do is we go to the instance that we encrypted this function here. So here I have all, let's disconnect this, connect to the SQL Server instance here that we just encrypted our function. So the databases, SQL Junkie share, and the functions. Here you can see a log symbol in this tool saying that this function has been logged or encrypted. So once you click here, show DDL script, basically this is throwing me an error. The SQL Server version I am using here is the SQL Server 2012, which is the release candidate 0, the available release candidate right now in for the SQL Server 2012 codename Denali. So this decryptor is not working for the SQL Server 2012 in server. So basically my SQL team might have changed the encryption algorithm that they were using, or they have changed them the way they store the encrypted stream. So now what we will do is I created a same function here in a different same function in the SQL Server 2008 version of the database. SQL Server 2008 version, here I use the encryption algorithm, and I created this in a simple database here. So we'll go here and connect to the SQL Server decryptor to that version of the SQL Server and see if we can still retrieve that function. So now here you can see the different versions of the SQL Server which is 11, which is 2012 Denali, and 10, which is 2008. So now we go to this function here. So this here, which is encrypted, and if I view the show DDL script, it is able to, let's close this. So if I show DDL script, it is able to decrypt the function by creating a dedicated administrative connection to the system use or the user data. So now we understand what schema binding does, and now we understood what encryption does. So we'll also look at the other different aspects of the properties of the user defined function. So now we learn the different components of the user defined function, and the next important question is the what is a deterministic and a non-deterministic functions. So basically there are two types of functions. If you any function in the SQL Server is divided into any type of the function here, it can be a deterministic or it can be a non-deterministic. So what is a deterministic function? A deterministic function is just it returns the same result anytime they call with a specific set of input values and given the same state of database. So this is a simple definition of a deterministic function, but it can be complex to understand, because what a deterministic function means is it results the same output with the same set of input when executed in a different times. So the function is same, the parameters are same, but it is executed in a different time. So if the output doesn't change, then that is a deterministic function. If it changes, then it is a non-deterministic function. So here you can see here the non-deterministic functions may return different results as each time they are called with a specific set of input values, even if the database state they access remains the same. So basically the function and the parameters are same, but executed at different times will give you different outputs. So so this is the difference between a deterministic and a non-deterministic function. I would advise you guys to go ahead and look at the SQL Server books online to understand it more, because this is kind of little bit complicated topic that you need to understand more in order to properly diagnose the issues in a user defined function. So we were able to categorize the user defined function to deterministic and non-deterministic function. Well, what is the use? I mean, what does it means to you when a function is categorized according to the different according to the what it returns at a different times, or what it is, if it is a deterministic or a non-deterministic functions. So here because if you want to use the user defined functions in the computed columns, and if you want to store those computed columns in the table as by setting the is persisted or value to yes, you have to the function has to be in written in a deterministic manner. So and it is not only in creating the computed columns. In order to use the indexed views, when a view refers a function, like let's say the inline function, and let's say we created a view using an inline user defined function that we just saw. If we are creating a index on the inline user defined function, that's good. I mean, you can still create inline user defined function. It may be non-deterministic or it may be deterministic, but if you want to create indexes on the columns of those views, then the function the inline user defined function must be deterministic. So that's where the issue is. So it's these 2 points which I just told here. I'm discussing the same is when to create, I mean, how you can create indexes on those computer columns, and how you can create the indexes on the views that refer these functions. So well, what are the user defined functions? Well, what are the deterministic functions that we have? The systems the transact SQL Server system functions that we have, or can also be categorized between the deterministic and non-deterministic functions types. So here, all the aggregated functions and all the string functions, the aggregated functions, the max, min, and sum, all the aggregated functions and all the string functions are deterministic. It means the output of these string functions doesn't change when executed in different times with the same parameters and the same state of database. So other than these two aggregate and string functions, there are also some other string functions that are deterministic in different categories. The date diff, the power, and different these are all the different deterministic functions that exist in the different other types of the function categories in the SQL Server. And also, when you use a cast or convert or checksum or isDate or rand, sometimes they may act in a deterministic manner, or sometimes they may act as a non-deterministic manner. So basically, I mean, if you still having a confusion of what a deterministic means or what a non-deterministic means, I can show you a simple example here. You can see I will write a new query here. So let's say select substring. This is a SQL JUNKIESHARE, and the starting position is 1,3. Okay, now here, as we know, substring is a deterministic function. That means if you execute this statement at any time, at any point of time, you must be getting the same output. So let's execute this. We got SQL. So even after half an hour, or even after 10 days, or even after any time in the future, if you execute this statement, it will give you the same 3 letters. So making this substring function as a deterministic function. The any function which does not do this is a non-deterministic function. So now you have a clear picture of what is a deterministic and what is a non-deterministic function. So here, the cast and convert, when we are using cast or convert or checksum or isDate or rand, these functions, these string converting functions, on some of these, they act in a different way when given different data types. So the cast will act in a deterministic manner until when used with the datetime or small datetime or SQL variant. The same with the convert. So if you are using a SQL variant as a source or a destination, your function is a non-deterministic. So I would suggest you to go to the books online and look at the topic called deterministic and non-deterministic functions to understand more between these. So now you have a pretty good understanding of what is a deterministic and non-deterministic function. We will go through a simple example here and create one. Okay, I mean, and one more important question is, how would you know if a function is a deterministic and non-deterministic? Well, basically you can look inside the function body, and you can judge it as a deterministic and non-deterministic function. But there are also other parameters that affect this behavior. So here I have here a simple let's say here, I have this simple scalar function here. So here this is a simple scalar function. What this function does is, it does not take an input parameter, but it returns an int. What it does is, I'm just oh, not this one, let's look at this one. This is the one which I want to guys you to look. Basically the function here, which takes a parameter called int, which takes a integer parameter, and it returns a varchar. So what it is doing is, here is it converting the data type from integer to varchar, and it returning the function, returning the this variable once this executed. So here um, uh, so so by looking at the function body, you can tell that this is a deterministic function, because you are using a deterministic conversion. There are no other things in the function that specifies that this is a non-deterministic function. But in order to make sure that this is a deterministic function or not, there is a property that you can check for the SQL Server. So why don't we just I'm just okay. So the property that you can check whether a function is a deterministic or non-deterministic is using the object property function, by passing the object id, which is basically the object id of this function, and also a question or a parameter saying is deterministic. So once you execute this statement, you will say 0. When it is 0, I mean, the object property returns only integer. If it is 0, then it is false. So this function is not a deterministic function. Well, you might have a question, hey, everything in the function body specifies that it is a deterministic, why it is not a deterministic function? So in order to understand this, it's a little bit complicated topic, so we have to go inside and see what really making this function as in another way, working in making this function to work in another way. So here we have this object property function we just use here, which is giving us an error saying 0. Remember the topic that we talked about, the schema binding. Before we go into even the schema binding, there are a couple of other properties that you need to look in the user defined function. Is what is the function accessing, what type of data is the function accessing. Depending upon the one property is the determinism that we just talked, and other two properties is the accessing user data or accessing system data. These three are the properties of a user defined function that we have to look out when creating user defined functions. So we looked at the determinism. Now we're going to look at the user data and the system data. So in order to check whether the function is accessing the user data or system data, if you execute here, here you can see, we will execute all these statements. Here you can see it is saying that this function is not deterministic and it is not accessing a system data, or it is not, it is I'm sorry, it is accessing a system data and it is accessing user data. Well, what is system data access? System data access means that user defined function, it might be accessing any metadata catalogs or any metadata of the SQL Server system tables, like catalog views or like dynamic management views or any kind of other system metadata, SQL Server metadata. When coming to the user data access, if you access any objects like user tables or any other user defined functions, then the property of that function of user data access is set to true. Here in this case, here we do not have any system data accessed or any user tables that are accessed here, but still the function has been flagged that it is been using the system data access. Well, when you first create a function, by default, when you first create a scalar user defined function, by default, if you didn't specify the schema binding option, the SQL Server thinks that your that the function body may contain some objects that may access the system or user. So in order to remove this setting or these flags here, you have to specify the schema binding here. If you specify the schema binding here, let's see, schema binding. So here let's alter this function. Now we change the function from normal to a schema binded function. So now if we can execute this these three statements for the function properties, now you can see the both user data access and system data access are set to false, and the is determination function is set to 1. Well, that is the one which we are looking for. So now we converted, or we changed the we changed the behavior of the function from non-deterministic to deterministic by adding a schema binding option to the function with option class. So what does the schema binding does is, when a function is specified the schema binding function, basically the SQL server analyzes the body of the function and it checks whether if there are any tables that it is binding to. If there are any tables binding to, then it flags the user data access to 1. In this case, we are not binding any function body to any user table or a system table. The flag has been modified to 0 and 0 here. So now we were able to convert from non-deterministic function to deterministic function with a simple option. So well, now we modified the now we modified the function from non-deterministic to deterministic. So we will also look at some other options that we need to. So it's just in order for the UDF function to be deterministic, it should be schema bound, which we just looked. So when function is created the first time, the SQL server sets up the two flags, the system data access and the user data access, which are basically the two properties of the function. So it sets up to 1. But as soon as you specify the schema binding, it checks the function body and verifies whether the function is really accessing a user or system data. If it is not, then it flags those settings. So it is just this slide is just the explanation that I just mentioned, explained here. So and these are the list of non-deterministic function. So all the configuration or cursor, metadata or security or system statistical functions are non-deterministic functions. The following functions will always be non-deterministics, but these functions can still be used in the user-defined function, but in case just the user-defined function property of the user-defined function is set to non-deterministic. That's the only difference. So now we are here. So we will go back to our original function here by creating this function without a schema binding. So now we altered, but if we execute these statements here, now you can see it is back to our original state, which still says non-deterministic, and it accesses system data and it accesses user data. So how can we use a function to create a computed column? How can we use a function in a computed column? Now let's create a simple table here, new table, and we create a column called id, which is basically the int, and also the description, which is so here in this here we're gonna use this function in this computed column to convert the integer to varchar. So now here we scroll down here. When you click the description function, you can highlight the properties of that column, and if you click the eclipse button, here is a formula. So now you specify dbo dot func just to make sure functes2. So we'll just copy this here, copy function test2, and in the okay in the input parameter integer, here in this table we specify the column that we want to convert. So here I'm going to convert the id here. Okay, id. So here I was able to save this, I was able to create a computed a column in the table using the function we just created. So if we try to save this, let's save this table as let's say test function. Okay, we created this table, so we will refresh this table section to get the test function. So here is the table. So here you can see there are no columns, but once I edit the top 100 rows, let's say 1 and 2 and so if we close this and if I execute this function, so here the id which is here, which is integer, which is converted to a description by using the computed column and using that function. Now in the computed column there is another option called persistence. What does persistence does is, when you set up that option to yes, the SQL server saves the data of that computed column in the table. So if you go to the design page of this page, you can see the computed column specification here. No, test function, oh no, here. So once you go to the computed column specification here, is persisted is set to false. So what does this mean is, right now when you query the table, it is just calculating the output of the function when it is executed, when the SQL query is executed. So if you want to save the data in the table, you have to change this option to yes. So if you see the yes, and if you try to save the table, you get an error message saying this function is not a deterministic function and it cannot be saved or it cannot be persisted because this is not a deterministic function. So this is one of the important property. When you want to use a user defined function in a computed column and you want to persist that column, or if you want to save that column in a table, or if you want to create the index on that column, that function has to be a deterministic. So we simply go to this function here and we simply use schema binding in order to see here. If you execute this function, it still shows this is not a deterministic function. So we'll go ahead and we will use the schema binding. Or not here. So once you alter this function with the schema binding, as we just use this, we cannot alter this. So what we'll do is we just test function design, go to description, and we change the computed column to nothing. So we save this and we go to our procedure, and once we execute, basically the error which is we are getting is you cannot alter a function because it is being referenced by an object test function. As earlier we created this function in this table, we used that this function in the table. It's not allowing us to modify the function definition. So here we alter the function again, so it is successful now. Now we will go to the text function here and we go to the design phase, and once we go to description and change the computed column to dbo oh, not here, formula, go to the formula section, dbo dot func tes2. in this we specify ied. So here we said we change this persisted column to s. So once we save this, you are now able to save in a persisted way. So now when you execute this query here, this value, as you change the persisted is persisted to yes, these values are saved in the table physically, not just it is not just displaying the result for us, but it is saving this converted value into the table. Now you will be able to create indexes on this column, as it is a persisted column. So that's basically the using the function in a computed column and creating indexes, and by depending upon a function deterministic manner. So if that is a function, if we have a non-deterministic function, we can use in the computed column, but we cannot persist that. So that's the only thing that you have to learn from this simple demo. So we learned uh, now we will now you can see here this scalar function here. What we will do is we will just a second. What we need to do is what I want to demo is how the performance affects does UDF, which do not access system or user data, has significant performance improvement. So what I want to show is depending upon the way the UDF does, or UDF is executed in the deterministic or a non-deterministic way, or way it accesses the user or system data, the execution plan changes or the performance effects. So in order to prove that, what I will do is I will go ahead to this simple function that I have written here. In order to do that, first I will be changing the schema binding option. So in order to do that, what I will do is I will go ahead in the test function, and I will go to the design page, and I will delete this column. So I'll save this, yes. So I deleted that column. Now I remove this function, I remove the schema binding, and I alter this function here. So now if you can see the function behavior will, which is not a deterministic, which is the earlier stage that we just discussed, and it accesses the user and system data. So now the thing I want to show here is, if a function accesses user or system data, and it is not a deterministic function, basically the execution plan for this function is varies for a deterministic or a function which does not access the user or system data. So here I have a simple update statement here. What is that? Is I'm updating a product table, and I'm setting a product model ID equal to 100, where function test product ID is greater than equal to 150. So here, if I click the execution plan, and as you can see here, now we have this options. If I click the execution plan here, if you go to execution plan, you can create a tables pool. What is a tables pool? Basically, the tables pool stores the data from the input into a temporary table in order to optimize the rewinds. So what it is storing the data, the BMK output list. So here, this query, in this query execution, it is storing the output of this function into a tables pool. Well, why it is that doing? As the system and the user data access for this function is set to 1, which means the SQL server thinks that it is accessing some tables and functions, so it may change, that underlying data may change. So if it thinks an underlying data may change, it creates a tables pool and inserts the data into the temporary table, and it uses only the temporary table. If it thinks the underlying data does not change, it will directly use the data from the result only. So it will not create a tables pool. So we will prove that. So in order to prove, we will first change this behavior of the function to a deterministic manner, into a deterministic way. Define schema binding. So I will modify this function. Okay, now if I execute this query with the execution plan here, the execution plan differs. Now you can see the tables pool is not there. So before even looking at the output, we look at the functions property. So it is not accessing system data, it is not accessing user data, and once we execute this query, it is now eliminating the tables pool. So the reason why it is eliminating the tables pool is it thinks the underlying data is not changing, so there is no need for the SQL server to store the result in a temporary place in order to utilize inside the query. So that's how you improve the function here. So although the scalar user defined function here, it is not depending upon any object, so it is better to use the schema binding option in order to improve the performance. So that is one of the important topic that I want to discuss here also. So now you have a clear understanding of what is a UDF and how it is executed, and how we can use to create computed columns and index the computed columns, and what is a deterministic and non-deterministic function, and how are they behaved, and how is that behavior affects when using the schema binding option. And so if you have any questions, please use the comment section down, and thank you very much.